next section is about architecture overview. It's a very high level, and when we talk about architecture overview, we talk about what are the key principles or guardrails we need to have in place to define data platform tree so that we have a right foundation. Next slide, please. So what you see is whenever we talk about, here you see some examples of technology. So then normally what we try to do is try to define serverless compute. And every hyperscaler now, for most of the purpose, including I have recently attended quantum computing on legacy system from Google and also quantum cryptography from IBM. Even these quantum things on legacy system. We are talking about quantum computers right now, but we are talking how this quantum cryptography or quantum compute can run on our legacy system. And that's where again serverless computing is important as well. So whenever we talk about instead of going for platform as a service or infrastructure as a service, we should target to use serverless compute. And that's where we consider the cost of these services, what we use for. It could be Lambda functions or Azure functions or cloud on GCP. So there are common technologies that spread across different hyperscalers. And there is, like, if you see all these hyperscalers provide similar services, they name it separately or differently, but what we will see is if you're working on hybrid cloud or multi-cloud, more or less, you will find similar architecture can be implemented across these, and that helps to have a pattern or anti-pattern to implement serverless computing. And serverless computing help in managing the cost. Also, one more thing is you can see the cost in the cloud. What has been observed is that cost of the services also go up based on what the hyperscaler cost it. So they can cost, there is a small print saying they can change the cost as and when the contract is like over 6 months and 1 year. And again, that's the key important part to consider. Should we consider using the same technology or the services, or we should move to different technology or services? Because not every technology will see higher cost. Sometimes, for example, if cloud run is expensive, why not run certain scripts and configure or schedule those? So there are different ways of doing it, but it's good to have certain practice in place and consider those cost reviews. Auto scaling is one of the it looks very easy when we talk about it as auto scaling, but auto scaling itself is sometimes complex. The reason being is when you scale up, that what workload or what threshold will you want to scale up, and at what workload you want to scale down. It's difficult to understand the workload requirement when the peak or sub-peak or local peak, and that's where we may scale down, and suddenly we see local peak coming up. Okay, for example, if 4 p.m. is a time where we see schools children go back home and there's a higher mobile usage, suddenly you can see or WhatsApp, suddenly those services will see the higher consumption from telecom perspective. And that's where auto scaling is very important to consider AI within it. And AI is a certain thing which helps in understanding the pattern over a period of time. So depending on the historical data, the models are trained and models can predict, okay, today is Saturday, there's no school, so load will be distributed in such and such way. And now it's coming Black Friday. Now it is an event day, right? And that could happen on Saturday or happen on Friday. So now Friday is not like a normal Friday, but it has certain now workload distribution. Some people will see, like some workload will see in the evening because people want to place orders and so on. So auto scaling is important in the sense to understand the pattern and proactively understand or predict it. Historically, we may have seen certain things, but having AI in place to predict those is very important as well. And there are now proper AI models to model it. And I have seen that being used to optimize telecom power saving, you can say, use case. So for example, if there are multiple towers, multiple switches, routers, should they run at with the full workload? Not. So what has to be done is, depending on the workload, traffic is diverted to different routers based on their capacity, and this distribution should happen automatically based on demand, and that's where AI is important to predict those and suggest or recommend what should be implemented, how it should be implemented, or control, all devices should be controlled. Data tier strategy, this is just a very high level. We have, like in every cloud or even in data centers, we used to have hot storage, cold storage, and we need to optimize data. Now, it's again a challenge. How do you and when you move data from hot to cold? Because multiple access within cold storage may bring the cost higher than the hot storage itself. So that's where the key design principle must be considered, and see when storage data really becomes a cold, and how the formula with for calculating cost for hot storage and the cold is optimum or break even, and when thereafter cold storage becomes a beneficial going forward. Now, this I explained AI, ML, inference, and pipelines. Now we also talked about data lake, data mesh. We have more data. We have data mesh events as well, and these all require certain on-demand scalability, and that's where again we need to consider how we can scale those, the pipelines, the inference, and we don't want to keep big pipelines for data when data need is small or small transfer happening. And there are different ways to do so. It's not only one way of getting pipeline. We can have streaming, we can have batch, FTP, and there are many ways. Legacy patterns also important to be considered when we say clouds. It's not always has to be streaming. It not always have to be like Kafka or some sort of queuing in place. We need to understand which is the optimum way of doing it to consider cost. Now, while defining these or considering this design, we need to understand what are the modern frameworks available. So when we talk about data lake, now data lake on Azure or on AWS or GCP have their own service or wrappers around it. And that's where we understand what are modern frameworks and support robust and scalable, maintainable data flows going forward. And this is where certain guardrails are important, like when we talk about zero cost by design, it has underlying design principles to be supported, like principle of modularity, interoperability, vendor neutrality, and so on. And when we can all these things under zero cost, then we know how we can configure or set up alerts for cost or manage these resources so that we achieve our objective of non-technical requirement, and avoid also locking in and keeping flexible our approach going forward. Okay, Charlie, next one, please. Next slide. Yeah, going on now, once we understand like the key principles, the architecture, we need to consider for our design of different workloads, of different type of workloads. We need to consider a structured phased approach to implement it. We need to understand how this approach or structured implementation achieve business goals. Now, key here is the first phase you see implementation approach. It talks about five structured phase. And what we mean by five structured phase is first phase involves assessment and strategy alignment. Then the second is about having the right architecture design, which we discussed earlier, the right tool selections or technologies and have best practices guardrails in place. And the third phase is more about we cannot directly try to implement in production. We need to do some certain pilot. Can we move to the next one, please? Sorry, yeah. Thank you. Then third phase is about pilot implementation and cost modeling. The cost modeling is important because it requires certain design as well. Now, here design, I mean, is tagging as well, tagging the structure of resources under project or the enterprise, and right tagging like there's a which project is belong to which department, or you can say which shared services it belongs to. And that's where tagging is important so that right cost model can be implemented, it can be monitored, reviewed, and controlled. And the next phase is about deployment, and then followed by uh, governance. So once we deploy it, optimize it, the next is governance. Cost is something we just continuously monitor, govern, and be configured for based on business requirement, business budget, and thresholds. We're going to control it so that the cost remains within those limits. And as I mentioned, circuit data is one of the key things. Many of us now start implementing those. We stop those services for not production workload particularly, but probably where we have certain like development, data science workbench, and so on, so that we understand key cost control parameters and FinOps principles, and sometimes they're automated as well. We don't want to have manual review or manual monitoring. These are automated, and system takes care of those when reaches those limits. Following, then next is agile delivery iteration. We know we are in agile world. It's not only agile delivery from application perspective. We talk about agile delivery and feedback from FinOps perspective as well. So we try to implement those agility in FinOps processes, FinOps implementation, and so on. And obviously, monitoring continuous improvement is the key here to maintain the cost control and keep tuning the key resources and workload. Yep, thank you. Can you move to next slide, please? Next one, please. Yep, thank you. So now, this zero cost by design on data platform 3 brings in certain benefits and return on investment. So what has been observed by implementing these zero cost design principles and guardrails, we can control the cost or reduce the cost or manage the cost, getting optimize it at 30% by intelligently scaling it, automating it, and by doing so, this 30% again is a ballpark figure. So some may achieve 20, some may, if we do it better way, may achieve 30 as well. And then the next benefit is ability and time to market. So once we have these guardrails and principles in place, these are reusable, these are standardized, and these can be implemented for each and every project and release in an agile world. And so when we release certain data product, solution, same principles are applied again and over again. This also helps in data accessibility and democratization, because the better the control we have, like data accessibility comes from also when data is moved from hot to cold. We don't want cold storage to be used frequently. We want to have data access and control. It should be managed and only exposed in certain scenarios or use case requirement, and also provide certain users. They have certain roles, RBAC control, and approvals, and so on. And that's where data accessibility and democratization becomes important as well. So not only data or business value perspective, what we are talking about is more from cost or FinOps perspective as well. And obviously, we talk about FinOps governance and also avoid vendor lock-in, where cost becomes a fixed cost. What we want is cost not to be fixed, but variable. So there is some fixed part of element always there, but variable is the one which we can control over a period of time. Next slide, please. Next one, please. Now, when we try to implement and get the business value out of these key, like again, we talk about different guardrails and different things of cost to build, principles, cost to run, cost to optimize, and cost to exit. We talk about uh, commitment here for each of those. And normally, we need to have technical specification in place so that when we create data platform, we understand or we know the parameters like cost of services, how these services compute can scale and how much it will cost on demand. Uh, Also, when we implement AI machine learning, we need to understand how these can be implemented by enabling real-time batch processing, advanced learning, and there are different models, predictive models. And again, one thing is, has been observed in any AI ML, there's a drift. So then we drift in the prediction. So prediction may change for similar scenarios, say from 40% to 30%. It will be because of change in data. So there will be it's called data drift, or it could be model drift. So the model or version we have used is now old, and we need a new model because it has gone to certain better algorithms, or maybe complete different model, right? And so there's a model version drift and there is a model type drift. All these things are important to understand in terms of the cost of AI and machine learning integration. And that's why it's important to continue do assessment of data drift, model drift, and model type drift. And all these three different types of drift are important to consider in our costing and to bring the zero cost. Now, data mass, data lake also important. We see a surge in data in petabytes now in data lake. And when we implement data mesh concept, it's important, it's managed by the business. Data mesh brings in ownership thing. So when we have business, they own their data, they understand their data very well, and they manage their data for democratization, usage, data access control, and so on. And secreting cost, I have discussed many times, with monitor, sometimes need to use, we have to get governance and trade framework in place. Next slide, please. Next one. Thank you. So working with financial services like retail bank, private bank, and government sector, I have gone through many of the actual use case implemented. And while implementing these, there are certain, you can say, challenges as well. And key challenges like sponsorship for these initiatives, the business who need to sponsor those, and how these can benefit them, how to buy business to implement these in place. Because sooner or later, business will have a problem when the cost goes up. Then coming back is and redesigning those cost more than if we do cost optimization or zero cost by design itself. So when we have architecture, we implement those principles and so on. We integrate AI for insights and optimize based on recommendation from those AIs as well. And all these works very well. So in financial sector or retail banking, particularly when I was a private bank, implemented circuit breaker on Azure. And it was like a separate script to monitor usage and we configure those services, like how we can have circuit breakers. Sometimes that question comes to picture. Circuit breaker is nothing, but when service is reconfigured and not available for use or consumption. So what we do is we try to keep monitoring this service usage, and when we see it has cost threshold of 95% or 98% or 100%, whatever we call put the threshold, these services are disabled immediately. So nobody can use it and there's no further cost to it. That's why circuit breaker is important in the financial sector. where there's a lot of data coming in, a lot of processing happening, and data scientists are running their models. Sometimes they forget to, or they create incorrect queries, joins, and so on. There could be various different reasons for it, for the cost, but we need certain things or certain breakers in place to use it. In government sector also I have seen now it's much more challenge in government sector because of the workloads are not very clearly defined. The groups or teams are not very well identified, like who should own the cost center or who should own the cost for that. There are a lot of shared services across the data platform, and it makes life much more difficult in public sector to implement these cost-effective measures. And also, hybrid data studies are also create complications. For example, I have seen AI model running on Google, but consuming data from Azure. So organization have started their data ingestion to Azure for certain workloads or processing. Azure was used more for like normally in many public sectors or workplaces. Azure is used for better integration of Microsoft products, and that's why you see a lot of applications on Azure. Google anyway is better on for analytics, AI and machine learning. So you have a better algorithms models available on Google. You cannot run Google model on Azure. So what we try to do is run those Google Analytics on Google, but have a gateway to Azure to consume this particular data from Azure. And that's where hybrid data studies are important. What data is stored where, and when do you need access across different clouds or even on-premise as well sometimes, or across cloud, or even like open data initiative within our UK framework ODI. It's important to consider these data movements across and having right data strategies for zero cost. Next slide, please. Next one. Thank you. So now there are few steps we need to consider for our successful adoption of data platform three principles and have comprehensive cloud cost assessment followed by FinOps readiness. And that's where update design issues are key to understand the zero cost by design. When we have those, there are underlying guiding principles, guardrails, like using serverless components, data mesh framework, automated cost controls, managing rules, and also AI-driven prediction. And here is always important is for success is there are three-step process. One is proof of technology. Always consider to evaluate the right technology to be used. There's a proof of technology is a simple proof of if technology will work or not. Then proof of concept. Then we try to build on top of the technology which we think is feasible or will help to implement the solution. We build proof of concept. And that's where we understand end-to-end integration of different technologies, platforms, and so on. And then there is a lighthouse demo for the end users of these users, where you try to show, oh, this is how it looks like. This is my pilot we have done, and this is the benefit you can see or gain, and this is how can you do configurations and control. And that's important for any business. And this has to be done within few weeks to few months time. We don't want this to be running long, like 6 months, 1 year. Nobody would like to wait that long. Proof of technology in a couple of weeks, proof of concept in 3 to 4 weeks time, and lighthouse type of application for them in 2 months time. And that's where business value or business is eager to implement going forward. And obviously governance collaboration is common across any organization. We need to have governance in place. So we don't want environment to be bloated or convoluted because of different ways of implementation of different projects. Some project implementing in one way, other in different way. It's very difficult to control thereafter, and technical depth gap may coming up. I think that's all for me today. I will be like to answer your questions, if any.
I always have questions.
For us again, you mentioned about AI at edge locations. I'm just wondering about the obviously cost benefits of that one. So if you've got an application, I'm just thinking of an example that we've got at the moment. You've got a centralized data store and you're using something like a binary classification model to label the data into one of two categories. Where we're currently doing that after the data has been collected and before it goes into the main data store, we'll run that model to classify it and label the data at that point. Are you suggesting it's actually cheaper to run that model at the endpoint? So if you've got multiple, different edge locations, maybe in different cloud regions and so on, is it cheaper to run that processing at the edge location than it is against where your central data store is?
Yep, exactly. So here we need to understand data lake or centralized repository gets very complex very soon. We end up having data ingestions, data storage, the way it's stored in data lakes and so on, central repository with multiple technologies when we talk about. And when we do similar thing, it becomes distributed. So what happens is the edge, you have limited data types, data format, and structure. The AI at the edge helps to implement those more effectively than try. See, AI, as we know, the bigger the complex it gets, its accuracy or confidence level goes down. So if you do at edge, the accuracy and the confidence will be higher. And also at the edge, we provide one more advantage. At the edge, when data comes to central repository, the ownership may be challenging. So from business perspective, we will not be able to, for example, if you move data into, say, Azure or Google somewhere, the data once goes in a bucket or somewhere, the business ownership will say, I cannot control it. It's difficult for them to understand the technical side of it, understand how it's stored and so on. But if it's an edge, the application or the data store underlying, for example, is Oracle or something, they own it, they know it, and they can manage better. And that's where this concept comes is effective to distribute. Like example, the very good example is like if you have a train with 8 compartments, is it good to have one engine pulling 8 carriages, or should we have one small engine at each carriage? And that's where now we see effectiveness coming in. If we have a small engine at each carriage, in failure, the point of failure not single point of failure, but small engines are more better to manage, control, and effectively helps in going for faster way. Like we can scale it from 4 carriages to 8 or 12, doesn't matter, because it's not centralized engine or one engine. Each compartment has its own engine to pull it. So if we get one more edge, we add one more edge application there. Hope that answered your question.
Yes, it does. Thanks, Atul.
I've got a question online from Asil Ali. I'm just going to read it out.
Yep.
From a research point of view, what do you see as the biggest challenge in adopting a zero-cost by design approach at scale? Is it more about the technical complexity of serverless and AI-driven pipelines, or about governance and FinOps practices that ensure continuous optimization?
Yeah. So technology is the easiest part in any implementation. It's the process and people. And when we talk about process, see, the process can be only implemented if we know FinOps policy. And again, what I've seen is these are upcoming solutioning, or you can say ways of the way we implementing is changing, agile, cloud, AI, and all those things. So understanding FinOps, like earlier we used to have a centralized financial department of finance controller, and they used to very well define the cost, fixed cost, and running cost. But the FinOps for cloud is completely different. We do not have enough knowledge of people in the organization to understand FinOps or the cloud, data, or AI. And that's where one first step is to understand or define or document the FinOps policies so that we have right configuration on those technologies. And then it comes to the final, the process, persons. Person is the very complex thing, right? As a data scientist, with all these policies, everything, if I am not aware of certain guardrails, I can leave the clusters running without having understanding what it means. I will think, okay, yeah, I have run something today. I can rerun, like today is 10 GB data. Tomorrow I can run 10 petabytes because today is 2000 hours. But it lack of knowledge, understanding from person perspective, it exponentially increases the complexity from data perspective. And that's where data scientists, data analysts, or so on, they need to understand how to manage this workload. And not only, but from technology perspective, when we deliver certain threshold or circuit breakers, it's important those people understand, like this is what it has to be implemented for them, and this is how they need to understand the process and optimize it. And now when we talk about optimization, it comes with the data understanding as well, which I think we have forgotten. Data understanding is the key as well. When we try to join two tables, and if a wrong join, we end up in more processing than what is required, or we incorrect as well. So understanding data, understanding the right joining those, and that knowledge is like going away, understanding those relationships between those entities. So something called business object model is very effective in such scenarios, where from business perspective, we define common terminology, those objects, which have underlying data sets within it, and how those are related. And that's also important to understand from person perspective, how we want to use it, and then manage it.
Thanks, Atul. That's really complete.
Can I add to that? I'm going to take you all on a bit of a history lesson, but bear with me, right? So I've had to manage budgets, right, for runtime costs, storage, etc., for data centers, and we're talking millions, right? We it's not pennies, pounds, or anything. We're talking millions, and we talk going back in the day, it was the cost of CPU and the cost of storage, cost of and you were basically, it was about physical, and you had to buy your resources to cope with the worst day of the year, which typically in finance is the year-end processing, right? So you've got a lot of wastage in between. So we're talking big bucks here. And I think the other thing, why governance is important and FinOps, is that we're talking about large organizations that have got lots of legacy systems. Yeah, and they don't run on Lambda. They don't run on Kubernetes. They don't run on them. They run on more traditional and subscription type costs. And keeping a handle on how much money is you need in your budget is extremely difficult. It's it really is. I think subscriptions, perhaps Atul, is something that kind of fits into that cost model. So that's the reality, yeah. But the question I've got really for Atul is, given that most organisations have this mass of legacy, mass of technical debt, mass of Oracle and AWS, not Lambda, and Azure, and all different platforms. What type of application in the use case should we be looking at to introduce? Is it more that you're using this new technology on, say, apps that are being developed? Or is it always at the analytics layer? Or where do you start introducing it? Because you can't uplift your ERP and say, I'm just going to run that on, So that's really the question I've got for you, Atul, is what kind of system would we start to introduce in an organisation that would basically exploit this new technology?
Yeah, so one of the way is to start looking or categorize data into data domain first, not the business domain. Because business domain is something which is more dynamic in nature, whereas data domains are more static in nature. So finance domain, HR domain, we see these data domains are stabilized. They have their ownership there. And then instead of, as you mentioned, there's a technical debt, like if we have Oracle, we will move to a higher version or move to Redshift or whatever in cloud or something like that. So first step is always start with the data domain equivalent. What we want to do here is, based on our data consumption layer, we try to define certain data APIs. It's good to have data product concept in place. Even if you don't have data product concept in place, based on data domain, define data API. Right. Now, data API can connect to Oracle currently or some other legacy database. In future, when we move to cloud or somewhere else, and user is not impacted. These APIs are specific to the REST API or Open API based standards. So there are different standards now being implemented. One is Open API based, which is very good. And also, if you see, there was one project done at 10 Downing Street for Rapid. So you can search for that Rapid. And there also they came up with the concept of implementing or exposing data as data domain. So it encapsulates the underlying technology, extract the data we need for the consumption, whether it's users, applications, or data warehouse or data lake, doesn't matter. And then slowly in future, when Oracle is end of life or there is migration, there's no impact or new impact going forward for the end user. We just try to reconnect those to right data stores and data location.